The lesson today is going to begin with a review of exponents. Exponential notation is a shortcut way to write multiplication of the same number. And there are a few different exponents that have special names. All right, x with a 2 above it is read as x to the second power, or x squared. Okay, so if you ever see an exponent of 2, we would call that squared. X with an exponent of 3 is read as x to the third power, or x cubed. Okay, so an exponent of 3 could be read as cubed. And then any other number, such as 4, x with an exponent of 4 is simply read as x to the fourth power. Okay, so exponent of 2 being squared, exponent of 3 being cubed, those are the only ones that have special names. Now, there are two parts to an exponential notation. Notice we've got the two numbers here, the 5 and the 3. The 5 is called the base. The base is the number or expression that is used as a factor in repeated multiplication. The 3 is called the exponent. And the exponent tells how many times to use the base as a factor in the repeated multiplication. In order to write in exponential form or as a power, the first thing you need to do is count how many times the base is used as a factor. And then you write the base and you use the number as the exponent. For example, I can see the number 4 is being used in repeated multiplication, so 4 is going to be my base. Now I just have to count how many times they used it repeatedly as a factor, and that's going to become my exponent. 1, 2, 3, 4. There are 5 4s, so this would be rewritten as 4 to the fifth power. Okay? 8 times 8 times 8 is the same number multiplying itself 3 times. Exponential notation would be 8 cubed, or 8 to the third power. The base is the 8. The exponent is the 3. The product or answer, well, we would have to actually do that problem in order to figure that out. 8 to the third power means 8 times 8 times 8. All right. 8 times 8 we know is 64, so we just have to do 64 times 8. And when we do 64 times 8, we get an answer of 512. And this is the product or the answer. When the directions state to evaluate the power, it means to find the answer to the product. Okay? And it's also important to remember that you never multiply the base by the exponent. In this example, 2 to the third does not mean 2 times 3, but it means 2 times 2 times 2. This is the expanded form, and we want the answer, so we're going to evaluate this. 2 times 2 is 4. 4 times 2 is 8. 3 to the first power is simply the number 3. Whenever the exponent is a 1, the answer is going to be the value of the base. 5 to the fourth power means 5 times 5 times 5 times 5. And now we're going to evaluate that. 5 times 5 is 25. 25 times 5 is 125. 125 times 5 is 625. Finally, 1 to the fifth power means 1 times 1 times 1 times 1 times 1. And that is simply just 1. Each example that we looked at earlier had a positive base, but it's also important to know what to do when the base is going to be a negative number. In each of these cases, my base is negative 1. And we're going to use that to figure out if we can figure out a rule in order to do what we should do when we're working with a negative base. So negative 1 to the first power, again, is just simply the value of the base, which is negative 1. Negative 1 squared means to do negative 1 times negative 1. And we just need to remember that a negative times a negative is going to be a positive in this case. Positive 1 is our answer. Negative 1 to the third power means negative 1 times negative 1 times negative 1. Okay, we just did negative 1 times negative 1, which was positive 1. 1 times negative 1 is negative 1. Negative 1 to the fourth is negative 1 times negative 1 times negative 1 times negative 1. Okay, we just did negative 1 to the third power. These first three is going to give us a value of negative 1. Negative 1 times negative 1 is positive 1. So negative 1 to the fourth power is positive 1. Okay, and negative 1 to the fifth power means negative 1 times negative 1 times negative 1 times negative 1 times negative 1. Negative 1 to the 4th power gave us a positive 1, so this is 1 times negative 1, which is negative 1. And so hopefully you can see a little pattern that we have going on here. Okay? If you notice, if I had a negative number, a negative base raised to an exponent where it was an odd number, 1, 3, or 5, the exponent was an odd number, my answer turned out to be a negative number. And so that's the first thing that we're going to write down for our rules. A negative base raised to an odd exponent gives a negative product. Okay, if your base is negative and your exponent is odd, you know your answer is going to be a negative number. All right, but a negative base raised to an even exponent, gives a positive product. Okay, and we can see that here, negative 1 squared and negative 1 to the 4th power. All right, when the base was negative and the exponent was even number, we ended up with a positive number. Okay, so that's one easy way that you can determine the sign of your answer when you're working with a negative exponent. Also, realize that if I'm going to be raising a negative number to an exponent, I have to put that number in parentheses like I did with all of these examples up here. Otherwise, it means something entirely different. So if you want to raise a negative number to an exponent, make sure you put it inside of parentheses. What happens when the exponent is a 0? Well, in order to figure that out, we're going to evaluate the following powers. Okay, 3 to the 3rd means 3 times 3 times 3, which gives us a value of 27. 3 to the 2nd power means 3 times 3, which is equal to 9. And 3 to the 1st power is just 3. Okay? So if I notice here, each time my base goes down, my exponent goes down by 1, my previous answer gets divided by 3. Okay, 3 to the 3rd was 27, 3 to the 2nd was 9, 27 divided by 9 is, divided by 3 rather, is 9. All right, 3 squared is 9, 3 to the 1st is 3, 9 divided by 3 is 3. So if I decrease my exponent by 1, my previous answer just gets divided by 3. So if my exponent is 0, well, I can't really expand that, but I'm going to follow this pattern here. I'm just going to take my previous answer and divide it by 3. 3 divided by 3 is equal to 1. So 3 to the 0 power is equal to 1. What about if the base was a 2? 2 cubed means 2 times 2 times 2, which is 8. 2 squared is 2 times 2, which is 4. 2 to the 1st is just 2. Notice this time, when I decrease my exponent by 1, my previous answer simply gets divided by 2 to give the new answer. Okay, so following this pattern, again, 2 to the 0 power, I can't expand it, but if I continue this pattern and I do 2 divided by 2, I again get a value of 1. 3 to the 0 power was 1, 2 to the 0 power was 1, and if the base has a power of 0, the answer will be equal to 1. The next part of the lesson is going to focus on order of operations. All right, and if we recall the order of operations, whenever we're trying to evaluate an expression, the first thing that we look for are things that are in grouping symbols. Grouping symbols. Okay, the most commonly used grouping symbols are parentheses, but they might also be brackets, which kind of look like square parentheses. They might be braces, which are kind of those squiggly lines that we can draw like that. And it might even be absolute value bars. Okay, if you have any operations inside of these grouping symbols, you need to do those operations first. Okay, so look for grouping symbols first. After we take care of anything inside of grouping symbols, then we evaluate any exponents. Once exponents have been evaluated, then we're either going to multiply or divide in order from left to right. Okay? We evaluate an expression the same way that we read a sentence in a book, from left to right. Whichever happens first, the multiplication or division, that's what you will do first. All right? And then finally, it's the same with addition and subtraction. I'm either going to add or subtract in order from left to right. So if you follow these orders of operations, you should always come up with the correct evaluated answer. In example 6, it says 14 minus 6 divided by 2 plus 12. I have subtraction, division, and addition. And following the order of operations from up above, I know that I'm going to have to do the division step first. So I'm going to first do 6 divided by 2, which I know is 3. I'm going to bring everything else down, 14 minus 3 plus 12. Okay, and now we're left with subtraction and addition. They're on the same level, so we go in order from left to right. 14 minus 3 is 11, and 11 plus 12 gives us a final answer of 23. In example 8, we have multiplication and subtraction. Multiplication is higher up in the order of operations, so I'll do my multiplications first. I have 2 times 13 and 2 times 7. 2 times 13 is 26, minus 2 times 7 is 14, and when I subtract, that leaves me with an answer of 12. Examples 9 and 10 show two problems that look very similar but actually mean two different things. Okay? In the first example, in number 9, notice that the negative number is inside of parentheses. We said earlier, if we're going to raise a negative number to an exponent, we have to put it inside of parentheses. So this means negative 4 times negative 4 times negative 4. All right, but in number 10, notice that the number negative 4 is not in parentheses. We would have to treat this like order of operations, and we said before in the past that a negative symbol out front by itself like this is the number negative 1. So this means negative 1 times 4 to the third power. Following order of operations, we would have to do the exponent first. So this would be negative 1 times 4 to the third power. 4 times 4 is 16. 16 times 4 is 64. So this means negative 1 times 64, which is negative 64. Okay, so these two look similar, but they actually do mean different things. Okay, so watch out for the parentheses. If it's inside of parentheses, negative 4 times negative 4 times negative 4. If it's not in parentheses, that negative is negative 1 times our exponent. A fraction bar is another example of a grouping symbol where we're going to have to figure out the values of the numerators and the denominators before we can do the last step, which is going to be the division. So looking at example number 15, in the numerator I have parentheses with 3 plus 4. 3 plus 4 I know is 7, so my numerator is going to say 62 minus 7. In my denominator, I also have multiplication inside of parentheses. 4 times 2 is 8, so this turns into 3 plus 8 in the denominator. Going back to the numerator, if I do the subtraction, 62 minus 7 is 55. And in the denominator, if I evaluate 3 plus 8, that gives me 11. And now that I know the numerator and the denominator, I can do my division, and 55 divided by 11 is equal to 5. Example 19 asks us to explain and correct the mistake in the problem below. So we had 7 plus 16 divided by 4 times 2. And then that turned into 7 plus 16 divided by 8. 7 plus 2 equals 9. And everything looks good, but if we pay attention to our order of operations, we'll realize that our mistake happened up in here. Okay, we had addition, division, and multiplication. Division and multiplication are on the same level, okay, and so should be done in order from left to right. This person multiplied before doing the division, thus leading to a wrong answer. Okay, so if we actually did the problem, 7 plus 16 divided by 4 times 2, we would have to do this division first. This is going to turn into 7 plus 16 divided by 4 is 4 times 2. Now between the addition and the multiplication, I'm going to multiply. 7 plus 4 times 2 is 8, and 7 plus 8 gives us an answer of 15. So pay close attention when you're working with your orders of operations.